All right, we're going to go ahead and start on E08, energy, thermal energy, and heat. So first of all, before we go any further, I think it's important to say that you need to go back over Unit 7 and some of the concepts that we learned there about energy and work to review over those. Okay, so now let's go on to the new stuff. So energy, as we know it, is the ability to work, is the ability to do work, and it is transferred by a force moving an object through a distance. When work is done on an object, energy is transferred to that object. Okay, this is an important concept. So, by definition, work is the transfer of energy, and it is measured in joules. Okay, so before we go any further, I think the most important thing to do right now, because this is a keystone concept here, is work equals the force times the distance. That is, a Newton times a meter gives you a joule. So, essentially what you have here is, you need to remember what exactly a Newton is. A Newton is a kilogram times a meter per second squared. All right? That's what a Newton is. And when you multiply that times a meter, you're going to get a kilogram times a meter squared second squared. All right? And that is going to give you a joule. This is going to be very important here as we learn some new calculations, because you will have to write out what a joule is in the long form. So write this down and be ready for it. Okay, so one of the first major forms of energy is what we call mechanical energy. It is the energy that's associated with the motion and position of objects. Technically, it is the sum of an object's potential and kinetic energy. So we write it like this. Mechanical energy is equal to kinetic energy plus potential energy. In short form, we use this abbreviations, ME equals KE plus PE. Now remember, this is going to be measured in joules. Okay, so kinetic energy is measured in joules, and potential energy is also measured in joules. Okay, and the overall amount of mechanical energy, therefore, is obviously measured in joules. So once again, mechanical energy is equal to kinetic energy plus potential energy. In some situations, kinetic energy will be zero and potential energy will equal to mechanical energy. In other situations, potential energy will be zero and kinetic energy will be equal to mechanical energy. It just depends. Okay? So for instance, if the kinetic energy is 0 and the potential energy is 5 joules, the overall mechanical energy will be 5 joules. Okay? And there can be different combinations of these as well. Okay? Mechanical energy could equal, let's say, 10 joules, and potential could be, let's say, 5 joules, right? And then that means kinetic will then be, will be 5 joules. Okay? So those two things have to equal mechanical energy in all situations, no matter what it is. So here's a good example to explain kinetic energy. So kinetic energy is associated with something that is moving, okay? So kinetic energy increases as mass and or velocity increases, okay? So the technical equation here, all right, kinetic energy, KE, is equal to 1/2 mass velocity squared, okay? So Let's take a look at this example a little bit more detail here. So you have two scenarios. Scenario one, you have two different mass objects, okay, and they are going the same velocity, okay. So according to our calculation, so velocity would be the same thing, but the masses are different because the bowling ball has a greater mass, so therefore it's going to have more kinetic energy, okay. In scenario two here, we have two masses that have the exact same, two bowling balls that have the exact same masses, but the purple one here is going at a greater velocity. So we would say, therefore, that this scenario, the purple ball would have the highest amount of kinetic energy. So let's take a look at one of these examples from the textbook. It says, calculating kinetic energy. A 0.1 kilogram bird is flying at a constant speed of 8 meters per second. What is the bird's kinetic energy? So step one, we have to figure out what we have. All right, so we have the mass, and we have the velocity. So our mass is 0.1 kilograms. Our velocity, our speed, because those things are interchangeable, mathematically speaking, for this example, velocity is 8 meters per second. Okay? So step two is we figure out what exactly we are trying to find, which is in this case kinetic energy. So we write down our equation, right? Kinetic energy is 1/2 mass velocity squared. Okay, so a lot of times students make a mistake here because they enter this into the calculator wrong, so you have to be really careful. I like to do it this way. So next step we do is we substitute our variables in there. So it's 1/2 our mass, which is 0.1 kilograms, and our velocity is 8 meters per second. So remember, the order of operations says we have to square our number first before we do anything else. Sometimes in a lot of situations, students like to forget the order of operation here, so therefore if you enter this into the calculator, you'll get the wrong answer, okay? So make sure you do it correctly. So do your square first, okay? And so, so 8 squared is going to give you 64 meters squared second squared. You're going to then multiply that times your mass, which is 0.10 kilograms. All right, and that'll give you a number, which will be 6.4. And then, lastly, the last thing you do is you divide, multiply that times half, or in this case, divide it by 2. I think that's the best way to do it. So, 6.4 divided by 2 gives you 3.2. So here you see your units in long form here. You have a kilogram times a meter per second squared divided by a second squared. And as we know from our couple slides ago, that equals a joule. So our answer is 32 joules. So here's another example. A bicycle rider with a combined mass of 110 kilograms is traveling at a speed of 8 meters per second. What is the kinetic energy of the bicycle? Okay, so we know we have our given information here of 10 kilograms and 8 meters per second. So we don't know the kinetic energy, and that's what we're trying to find. So in step 2, we're going to write out our equation here. Kinetic energy is 1/2 mass velocity squared. All right. So the last thing we do is we input everything, our values, our 10 kg and our 8 meters per second into our equation. All right, so what we got? Now we got to, let me show you, we have to go through here and do this in a certain order, otherwise we'll make a mistake. So 8 meters per second squared will give you 64 meters squared seconds squared, right? And we multiply that times the 110 kg, right? And that gives us, I do believe, 7040. And what are our units here? Kg times meters squared seconds squared. All right. And now we take this and we all divide this up by 2. Okay. So our final answer is going to be Ke is going to equal 3520 joules. So the first example was pretty straightforward, right? You just plug in the equation and go. Well, let's look at one here where we have to do a little bit of extra algebra, all right? So here we go in example 2. The kinetic energy of a bowling ball traveling at a speed of 4 meters per second is 50 joules. Find the mass of the ball, okay? So what are we given? We're given the kinetic energy of 50 joules here, and we're given the velocity of 4 meters per second. The unknown thing is we're trying to find the mass, okay? So first thing we do is we write down our equation, right? And now we have to manipulate the equation a little bit based on our variables. So our base equation here is kinetic energy is 1/2 mass velocity squared. So now we have to manipulate that a little bit algebraically to find mass. So when we do, right, it is now mass is going to equal 2 Ke divided by velocity squared. Okay? So from here, we will substitute all our variables in and solve. So once we do that, we have 2 times our kinetic energy, which is 50 joules, divided by 4 meters per second, and everything in there is squared. All right? And so when we do that, we get 6.25 kg. So just so you know, let's go ahead and write the units out long way, because you'll have to do this on your quiz to show that you understand how your units cancel out. So let's show how you do that. So what exactly is a joule? A joule is a kilogram times a meter squared divided by a second squared. All right? And if we take that and we divide it by a meter squared second squared, because down here it's meters per second, and everything is outside the parenthesis, inside the parentheses, so that means everything is squared. Okay, so it's meters squared times second squared. All right, and so what's going to happen here is, change my colors here, these are going to cancel out, and you're going to be left with a kilogram. Okay, so if you have to manipulate the base formula, you will have to know and show how your units cancel out, okay, and how your final units are derived. Okay, so be ready to do that. All right, the next part of the mechanical energy equation is potential energy. So potential energy, by definition, is energy that is stored because of its position, such as height or as in shape. It has the potential to do work. So, there are two types of potential energy. First of all is the what we call the elastic potential energy. All right, and this is the potential energy that is stored energy that is either stretched or compressed. So you have a pole vaulter here, right? When the pole vaulter bends with the pole here with his body weight and his velocity, he's able to stretch the pole here, and as he continues to go up, he can then have that energy released in the form of kinetic energy, right? But all the potential is coming from his the elasticity of the pole and how he manipulates his body. Okay. The second example here is the bow and arrow. Right. The bow, as we know, is able to stretch and compress. Okay. So when the archer pulls back the bow, he's putting all this energy into the arrow, and when he lets go of the arrow, boom, now that potential energy is going to be transferred into kinetic energy. The second type of potential energy, which we're going to do some calculations with, is the gravitational potential energy. All right, and we call this GPE for short. Okay, so this gravitational potential energy is pretty easy to calculate. You have the potential energy, PE, is equal to mass times G, in this case, gravity, and height. Okay? So if you look at the two skiers here, this is pretty much common sense, right? If you have two skiers that have the exact same mass, right, but are on different heights, right, the skier in blue over here is going to have the greater potential, all right, because he is at a higher distance. Okay. The second one over here, if they're at the same height, but the masses are different, okay, therefore, the one that is heavier in terms of mass is going to be have the greater potential to go faster. So here's an example here. Suppose a diver at the top of a 10-meter high diving platform has a mass of 50 kilograms. You can calculate her potential energy relative to the ground as follows. So potential energy equals the mass. Right, that's what we have given here, right? It's 50 kilograms. Right? We know gravity is a constant, so that's 9.8 meters per second squared. You should know that. You should remember it. And we know that she is in a 10-meter high platform, so that's 10 meters. So we multiply all those out, and we get the answer down here is 4,900 joules. So here's another example. What is the gravitational potential energy of a 5-kilogram object resting at a height of 3 meters off the ground? So here is our given information here. Whoop. Put my pen on the right one here. Okay, very good. So here's our given information. We don't know the potential energy. So the first thing we're going to do is we write out our equation that we're using. Bada bing, bada boom. All right. Then the second thing is we substitute everything in. There are 5 kilograms. We know gravity is 9.8 meters per second squared, and we know that the height is 3 meters. So we take our kilogram times our meter per second squared, and we multiply that times a meter, right? What happens in the end? These meters, a meter times a meter gives you a meter squared, right? So that's a kilogram times meter squared second squared, which equals a joule. All right, so our final answer is 147 joules. So for our fourth example, we're going to solve for one of the other variables. Okay, let's see how this works. So the gravitational potential energy of a 10 kilogram object is 249 joules. What is the height of the object off of the graph? Okay, so our given information is here. We know the potential energy, 249 joules, and we know the mass, 15 kg, and of course we know gravity, right? So we're trying to find height. So in order to do that, we have to manipulate our base equation here. So our base equation is this one, but when we're solving for height algebraically, we have to manipulate it around a little bit, right? So height is going to be potential energy, right, divided by mass times gravity. All right. So in this situation, you would need to write out joules in the long form. Remember, a joule is kg times meter squared second squared. Okay. And now we have, below that, we have our kilogram here and our gravity here, which is meter per second squared. All right, and once we cancel these out right here, and we get that left off, what is left? Meters. Okay, so the final answer is 2.0 meters. All right, so that's how you work the mechanical energy calculations. We showed you how to do both potential, gravitational potential, and kinetic energy. All right, so you have to read the questions very carefully to determine which equation you're going to use, all right, which base equation, and sometimes you will have to you will have to manipulate the base equation to solve for one of the other variables. So be sure to show all your work, show how your units are canceled out. Good luck.